Hello developers, let's start developing. Today we're taking on the 9 tasks, which means we are in the last third of the Advent of Code 2025. So let's get running. We're gonna need to go to the proper folder and everything. We're over here, so we're gonna set up the day 9. By the way, so far I haven't run npm run all, which should run all our tasks. And to be honest, I haven't even checked that we are actually running on the proper way. So it seems that day 8 and day 2 are kind of spending the most time so far. So those are some places that we can optimize maybe. But let's go back to day 9. Here the input is trivial. We have just a set of coordinates in a matrix. All the numbering starts from 0, so 7, 1 is 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7. Is it? Yeah, so column 1. Let's see how this works. So we have 7, 1 and 11, 1. So on the first row, 7 and 11. And then on the third row, we have 2 and 7. Yeah. So the first, it doesn't really matter, but maybe we will want to see. So the first line specifies the column and the second one specifies the row. Okay, we can work that through. So let's see what we have. So not day 8, we're done with that. Day 9. Let's try the small input. And first of all, of course, we're gonna see whether we need to paste it. So we're gonna get an array of points. So type point is basically a tuple of two numbers. We're not gonna use x and y because we kinda have it either way. So this is gonna be an array of points, which means that after we read it, we're gonna need to lines.map for each line. Yeah, trim it, why not? Split it on a comma and map it with a number as point, which means we will get this thing as an array of points. Yep, so we just need to return that and everything is okay. Let's run it. Start debug 9 so we can see the input actually. Yeah, we got all 8 points from the input. 1, 2, 3, 4, 8 points for the input. And now we need to find the maximum rectangle where 2 of these points are basically the corners. So we can have this rectangle, which is just one grid, or we can have, for example, this rectangle. Or how do we? There was a way in which you were able to select columns, but I have no idea how to do that. Anyway, which means that we will need to take all of the pairs of points. So loop through all pairs of points. Yeah, that's just all that we need to do. Let's see if it generates something. Nope, it generated just the wrong thing. So we're gonna have a for loop, and we're not gonna use an I, we're gonna use the, actually we need to loop through all of the points using the findex, and then we're gonna have, yeah, those are the first axis and the y. So next we're running to the second one, and it calculated something wrong, because we don't actually need that. We don't need the distance, we need the area. But getting the all four values is kind of okay in our book. So now we need to find the area. Well, we need to find the max x and the min x. So we're gonna find the corners of this rectangle. And so the corner is gonna be the bigger of fx and sx, with the bigger on the x and the y. That's one of the corner, the top bottom corner, and the other corner, the top left corner, is gonna be the minimums. So basically it doesn't matter if we have something like this, whether the points are here or here and here, this is the same rectangle. So now we need to determine the area. But it's not gonna be this much because we're counting the first one. So it's gonna have max plus 1. We're gonna need to add 1 to both of these dimensions, because otherwise if we're counting this rectangle we will get a 0. So 7, 3 and 2, 3. We need to find, because 3 minus 3 is 0, but other than that, we're gonna multiply 7 minus 2, which is 5, plus 1, which is 6, by 3 minus 3, which is 0, plus 1, which is 1, so 6 by 1 to get 6. And that's all that we need to do to solve part 1. So that is the area. We will define something called mean area, which is, we need to find max area. And we're gonna set it to 0. And now we're gonna have, if the area is bigger than the maximum area, then that's the maximum area, and just return the maximum area. Looks straightforward, we should get 50. Yep, and we're getting 50. So now we're gonna get to the whole big batch of numbers. Let's see how many we have. We have 500-ish, which is okay, well, performance-wise. So this is gonna be 500 times 500, something like that. And the biggest area that we get is this thing. Let's see if this is correct. Of course it is. Let's see what they have for us in part 2. If part 1 is easy, usually part 1 is not as easy. They can only switch out tiles that are red or green. So your rectangle can only include red or green. What is a green tile? Every red tile is connected to the red tile before and after by a straight line of green tiles. The list wraps, so the first red tile is also connected to the rest. Tiles that are adjacent in your list will always be on the header of the same row on the same column. So the list will always basically describe a path through the map. So it starts on 7, it's going to end on a 7, so we're going that to that, that to that, that to that. Yep. Yeah, let's read through it for a while. So after thinking it through and reading it through and trying out some ideas, I think this is gonna be our first two-parter video, because now we need to actually make a shape out of our edges, out of our nodes. So they're not nodes, they're just defining, our input actually defines edges on this thing. We need to do some kind of a closed off polygon, and we need to fill it, and then and only then we need to find out the biggest rectangle. So we have a bit of problems. My initial idea of basically brute forcing everything, that will totally work for this size of 12 by 12, let's say, matrix, but a real output is something like 100,000 by 100,000, which means to store that thing properly in memory it's gonna take around 40 gigabytes. I mean, we can do that, but I don't think that's the way that we should solve it. Our first solution was along these lines, so I guess the second one will be at least in order of magnitude similar, and this is kind of 4 billion. I kind of don't want to check. Now we will need to check each and every point whether it's inside or not, and I kind of don't want to check 4 billion points. So I'm going to be thinking of a better solution that we might want to try out. But in the meantime, don't forget to click like, share, subscribe, comment if you have any ideas, and keep developing.